Hi, welcome back to the channel. We have already discussed first three problems of today's contest. That is in a separate video. So if you want to look at the explanation of those problems, please check out the other video. So in this problem, we are going to discuss the fourth problem. So in this problem, what you have to do, you are given two string as a target, each of length n, and you have to find out the lexicographically smallest string, which is a palindrome and also a permutation of given string s. So you have to find out the smallest permutation of s, which is a palindrome and which is strictly greater than the target. And if there is no such permutation exists, just return an empty string. Yeah, it's a backtracking problem. Let's see how we can approach it. I would like to discuss fourth problem through the code because I felt like this problem is kind of a not much intuitive problem, so it would be easy for you to understand through code itself. So the implementation of this problem is done using backtracking, right? So I hope you are aware of what backtracking is in the coding. So I would highly recommend to solve at least one backtracking problem to understand it properly, right? So what I'm doing here essentially, so first we know that we have to find out the smallest lexicographical permutation of s, which is a palindrome and which is greater than the target. So if it is a palindrome, then how many characters it can have that has odd frequency? Just one, at most one, right? For example, a b b c b b a, right? We know that if it's a palindrome, the first and the last character is going to be same, second last and the second character is going to be same. So there would be only one character that has the odd frequency, right? At most one in the palindrome. So for example, here c, the c has the frequency of 1. So there will be just one, at most one, like it could be 0 also. For example, a b b and a, so there is no odd character here, right? So there is no character that has odd frequency, so this is also palindrome. But if you have two characters that has the odd frequency, then that cannot be a palindrome. So here that's exactly what I have checked here. So this is my count array actually. So this will store the frequency of each of the characters. So go through each of the character and then just increment the frequency of that character. And then what I have done here, I have tried to find out what is how many characters are there that has the odd frequency. So go through all the characters from 0 to 26, because we know that the string consists of lowercase English alphabet. So if the count is odd, so you can check by taking the modulo. If the count is odd, just increment odd plus plus and find out the mid character, right? So let's say this is my mid character, because we know that there would be at most one mid character. So this is my mid character, and then just divide. And one more thing, so the idea here is that we know that in the palindrome, the first half, like the right half is the mirror image of the first half, right? So we will try to build the first half only. That's why we have divided the frequency by 2, because we want to build the first half only, because we anyway know that the right half is going to the mirror image of each other. That's why I have divided the frequency by 2. So I have made the frequency half. And after that, what I'm doing, I'm just checking how many characters are there that has the odd frequency. If that is more than one, it means that there is no palindromic permutation possible. So just return empty string. Otherwise, this is my path. This path would tell you. How many So what is the order of characters in the first half in this path? So for example, here the path array would be consist of a, b and b. A, b and b. This is the mid character, right? This is mid, and since we know that the right half is going to mirror image of each other, so to build the whole string, what we can do, we can find a, b and b is already there in the path, plus mid character, plus mid, plus thus reverse of it, b, b and a. So that way we can build the original final permutation of it. So that's what this build function would does. This build function would essentially take few of the arguments. First one is path, the second one is count, the frequency, third one is target, this target. Then for this the fourth argument is the big. This big essentially tells you, if you have, let's say I am at index I currently, for example, this big, if this big is true, it means that this is already greater than target, because we have to find out that permutation which is more than target, right? That's why this big would tell you whether like you are currently more than target or not. This big. Mid is the mid character, like as I mentioned here. For example, C is the mid character and N is the total length, right? So now let's see what this function is doing. So here if you see, we have first check if your answer is, so this is my answer essentially. So just check if your answer is non-empty, means that you have found the answer, then just return true, like you have built it. Now take half, so half is going to be n divided by 2, right? The total size of the string divided by 2. Now check what is your path size. If your path size is equals to half, it means that you have already built the half of the final permutation, right? So if you already built the half of the permutation, means that we can build the original string, right? So this is, so what is my left part? Left part is this path dot begin, path dot end, essentially all the characters in that path. This is my left, plus right half, and right half is going to be the reverse of it. That's why see the right is equal to the reverse of the left one, right? Right. And so the total so the final palindrome is going to be left. So if the frequency is odd, then there would be a mid character. If the frequency is even, then there won't be any mid character, right? So that's why if the frequency is odd, your final string is going to be left plus mid plus right, right? And right is essentially the mirror, like the reverse of left. And otherwise, if the if the total length is even, then the total final string is going to be left plus right. Then just check if that is more than target. If the final palindrome is more than target, means that this is a valid palindromic permutation. Then just return, just update your answer. Answer is going to be your current string, and just return true. Otherwise, if that is less than or equals to target, means that you have to still do some work, like you have to still backtrack couple of characters, like in order to achieve that. So just return false, right? And if the path dot size is not equals to half, means that you still have to find couple of characters, right? Now let's see what I'm doing here in that part. So here what I'm doing, I'm going through like all the characters from 0 to 26, like from A to Z, right? I'm going through each of the characters from A to Z. But here there is a catch. Let's assume if you already have if you already have big equals to true, for example, if your big is already true, it means that you are more than target. Then you can choose any of the character at that place, right? Like, so at my current place, I can keep any of the characters. But if my big is false, means that my current build string is not more than target. Then you have to start from target of I. So here if you see here, that's what I'm checking here. First check if your count is at least like if there is any character to be taken or not. So just check if your frequency of count is equals to 0. If that is 0, just continue, like you cannot take it. Otherwise, if you're not big and that character is less than target, then also continue, because we know that if my not big, not big means I am small currently. If I am small and also my target is less than and my current character is less than target of I, means it is not a good string, right? So it will be invalid string, because you have to make greater than target. So just also continue. Otherwise you can take this character. If you can take this character, just push back, just keep that character into the path, decrement the count. Now your new big is going to be either you already more than that, like if you are already if you're already big is true, or if big was false, but if your current character is more than target, then also it is fine, right? So then also for the next character, your big is going to be true. So your new big is going to be either previous big or your current character is more than target. Then you know, so this is your new big. Now what you do, you call that build function again. So build path count target new big mid and n. And if the build function returns true, means that you found the answer, then just return true. Otherwise, now you have to backtrack. So whichever character you have added at the end, right here, so you have inserted c plus c character, c plus a. Now you have to pop back, and now you have to go to the next one, next possibilities. So here what essentially we are doing, we are keeping a, then we are checking if you can build it. Otherwise you remove it, and then you try to keep the next character, then you try to keep the next character, and so on. And that's essentially what backtracking is. In backtracking, we're trying to find out the most optimal answer by doing in step by step. In first step, take the first character, then try to see if you can build it. If you can build it, then that's good. Otherwise, go to the next character, and so on. And since we are iterating from a to z, so that will always be the minimum palindromic substring possible. So yeah, that's all about the explanation, like the code. Like if you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.